Intermediate Algebra, Section 7.8, Multiplication of Complex Numbers. To multiply square roots of negative real numbers, we first express them in terms of I. So when we're looking at this first example, it might be tempting to take the square root of a negative times a negative is a positive, but this would be incorrect. With this in mind, when we multiply square roots of negative real numbers, we need to first express them in terms of I. So this first example would be square root of negative 1 times the square root of 100 times the square root of 4, which is the square root of negative 1 times the square root of 4. Simplifying from there, square root of negative 1 by definition is I, square root of 100 is 10. Another square root of negative 1 is an I, and square root of 4 is 2. We have multiplication of these four values, which we can multiply in any order due to the commutative property. So rearranging and putting the integers multiplied together first, 2 times 10 is 20, with the I times I is I squared, and using the definition of I squared, which is equivalent to negative 1, our final answer is negative 20 for this problem. Similar with this next one, you might be able to do this mentally, but just to show you how this would simplify, similar to the last one, square root of negative 2 can be broken down into square root of negative 1 times the square root of 2. Square root of negative 3 is square root of negative 1 times the square root of 3. The square root of negative 1 is I. Can't do anything with square root of 2. Another I and square root of 3. Simplifying this, we have an I times I if we use commutative property, which gives us an I squared. Square root of 2 times square root of 3 would be the square root of 6. And again, we're looking at an I squared, which is equivalent to a negative 1 times the square root of 6, or negative square root of 6 for our final answer. And as I said, you might want to try doing some of these steps mentally, particularly as you've worked through these problems and get familiar with the process. In this next problem, we can use the commutative property to rearrange the multiplication of negative 4 times I times 6 times I and put the integers together and the i's together. Simplifying, negative 4 times 6 is negative 24. I times I is I squared, and we saw that I squared is a negative 1. So we have negative 24 times negative 1. A negative times a negative will give us a positive 24 for our simplification on that In this next multiplication with complex numbers, you can think of this as a monomial times a binomial, using the distributive property to simplify. Negative 2i times 1 is negative 2i, and a negative times a positive is negative. We have a 2i times 4i. Well, there's nothing that we can do with the first term, but the second term we have four things multiplied together. We'll put our integers together and our I terms together in order. Simplifying that, 2 times 4 is 8. I times I is I squared, which we've seen that several times now is equivalent to a negative 1. Negative 1 times the negative 8 will give us negative 2i with a positive 8. It's general practice to express our answers in the form of a plus bi, and so we would rearrange this addition using commutative property, putting the real number first and the imaginary number second. In this last example, we have what looks like a binomial times a binomial, and we do use the FOIL method to simplify. Multiplying first terms together, 2 times 3 would give us a 6. Outside terms multiplied together is an 8i. Inside terms multiplied together gives us a 3i, and last terms together, I times a positive 4i would be a 4i times I, or I squared. Simplifying, we have a 6. We have two imaginary numbers where we add the coefficients. 8 plus 3 gives us 11i. And here we have our I squared again, which by definition is -1. Multiplying then the 4 by -1 gives us a -4 that we can combine with the 6. 6 plus a -4 is 2. And we have the 11i that we simplified before. So there is our answer in complex number form.